Hi everyone, Mark here from Aero JTP in Sydney, Australia. When I'm not online with Renee Rosenträger developing the SolidWorks CAD files for our 3D printed remote control jets, I get involved in a bit of material testing, and in this particular video we'd like to introduce you to ASA Aero by Bambulab, and what we'll be looking at is how we can print paper planes and get some results in ASA Aero and compare that to some of the other filaments that are available. So if you're interested in this project, stick around and we'll take you through it. For all our current Aero JTP models, Renee and I have been focusing on optimizing our designs for the use of lightweight PLA. Since the introduction of a new material called ASA Aero from Bambulab, we are exploring the opportunities of using this and seeing what advantages and disadvantages ASA Aero presents. So as a bit of a fun exercise, I've decided to model a paper plane that I used to build as a child and then see how ASA Aero compares to other 3D printed materials. Firstly, what exactly is ASA Aero? Well, ASA stands for acrylonitrile styrene acrylate, and it's an advanced material. When 3D printed, it foams actively, so the temperature of the nozzle causes the material to expand and thus making it a lightweight version of itself. As ASA is temperature sensitive, the higher the temperature, the more foaming action is possible. The temperature range typically goes from 240 to about 275 degrees Celsius for ASA Aero. Having been printed at such high temperatures, ASA Aero is also very stable in outdoor conditions, and sunlight won't cause your parts to buckle or bend. One of the challenges of the self-foaming feature of ASA Aero is that it continues to foam even once the printer has stopped progressing the filament through the nozzle. So when the nozzle is not active or moving, ASA Aero will tend to purge out of the tip of the nozzle and cause stringing or overload of material on a particular spot. If retraction settings are not turned off, then the foamed ASA will get drawn back up into the cog drive gears, causing major clogging. The recommended process is to get a butane torch and an Allen key with a little round knob on the end of it, and you can see I've used this one quite a few times. So heat that up, get it nice and hot, not red but hot. You can see it's already gone red there, and we now plunge that into the little plug on the end of the unit and push that in as far as it goes before it cools. And then we cool that down, and hopefully with this, and now we can pull out the blockage. So it's really important that that Allen key has a little round ball head so that it really grips onto the blockage. Now you can see that whole section there is ASA Aero. It was fully plugged inside of the extruder head. So now that that's all clear, we should be able to get straight back into it, install it again, and start printing ASA Aero once again. Being such a challenging material, it took me a couple of months to dial in the settings for ASA Aero, and prior to that I had a lot of surface defects and blobbing occurring on the prints that I was making, until I finally found some settings and discovered a sweet spot whereby my prints were coming out perfect, and was very happy with the results. Having overcome the print setting challenges of ASA Aero, I decided it was time to set up and prepare for the paper plane challenge. Alright, what I'm going to do here is demonstrate the particular paper plane that worked really well for me when I was a kid. Used to enter in a lot of aircraft competitions or paper plane competitions, and this particular design served me really well. Not too sure where I learnt how to build this. It may have been in a publication or from a colleague or a friend, but it's a very simple design. And see here, split the A4 page in half. We now fold that over approximately about 1.5 inches from the end. I don't know, in millimeters, that's about 40 millimeters from the end there. If we want to get scientific, 45. So, and then we bend the edges back. Like so. And a big trick here for the central balance point is this fold back here, and you tuck the plane to the outside, fold down the wings, So here we have the paper plane, and I'm not too sure how well this is going to fly, but you can see that's just a beautiful glider. To be able to create 3D printable data, I needed to develop a 3D model of the previous paper plane, and to do so I used SolidWorks. Here, using surfaces that were 0.4 millimeters thick, I played around with offsets and body moves and commands to flip and rotate the parts to mimic the paper plane folding process that had just taken place a few moments ago. One of the key features in the 3D model that I wanted to replicate was the weight buildup of paper, and so in this instance here you can see the numerous surfaces that I'm building up, trying to get a similarity in the thickness of material being built up, so that the center of gravity of the paper plane would be maintained and that I would hopefully not need any extra nose weight to have these paper planes fly. Another important detail with this particular model was to trim the tail of the paper plane. The original paper plane design did not allow for a flat surface whereby the object could be printed standing vertically on a print bed, so I needed to make sure that the 3D model had a nice clean surface whereby the tail end of the paper plane could be placed on the print bed flat and level. After a couple of initial prints, I realized I could not have the outer wing tips unsupported. This led to the creation of some winglets, which did not replicate what was happening on the actual paper plane, but was required so that we had some stability in the 3D print. After the test print of this particular design, I discovered that the gaps and the spacing that I had left were undesirable for the 3D print, so it required me to come up with a new design, a simplified design, and one that would still replicate the paper plane model but be more optimized for 3D print. As part of the paper plane test, I've prepared ASA Aero versions of the paper plane. Different settings. The very last settings, the lightest one of those, was 0.3 wall section, so it became a bit messy. Here we have the high temperature lightweight PLA from Comparative, and here's some basic PLA, and we have the PLA Aero, which is very brittle. I'm finding you can just crack the wings by flexing that, so I'm not very happy with the outcome of the ASA Aero. And then here we have some earlier designs where I tried to totally replicate the structure of a paper plane, and as you can see here, the results of the printing weren't spectacular because I'm jumping across gaps. They look rather damaged. So all in all, weight comparisons of these, we have ASA Aero at 9 grams. We have high temperature lightweight PLA at 10 grams. We have the PLA Aero at 9 grams and 17 grams for normal PLA. So you can see there's a real difference in the weight between the foamed materials and just the solid PLA plastic. Now the big check and test will be how these all fly. So we'll get to that in a minute. All right, just to weigh the paper plane, coming in at 5 gram. And there we have the lightest, most possible feature there. I'm not too sure what the thickness of the wings are, but on all these prints here, apart from the thinnest lightweight ASA Aero, this was a 0.3 wall section, still comes out about 0.4. All the other wall sections for all the other designs were at 0.4 millimeters. This is one of the nicest prints, the surface area and the surface finish on this one. Very nice and clean. So we'll see how they now fly. Like a rocket. Pretty good. That was the high temperature lightweight PLA.
Where did that go? Where is it? Where? I don't even see it. Oh, there we go. not bad.
Low temperature, lightweight PLA. Made it the furthest, but you can see, look at the damage, it's very brittle. It's starting to crack, and that's not a good sign. PLA Aero is still very robust, hasn't cracked. All right, in order, we had a paper plane, flew very gracefully and had a lot of airtime. Good distance. The PLA didn't sustain such great performance. It's very brittle and very heavy. It did fly like a rocket, made probably the same distance as the paper plane.
Just a bit further.
Then we had our high temperature lightweight PLA, not bad, but you can see already in the front, it's very brittle, starting to crack. ASA Aero, this one here, very well maintained, doesn't have any damage to the nose. There seems to be good robustness, very rigid and no cracking. We have the super lightweight ASA Aero. This is where I printed at 0.3 wall section. You can see it's foamed, over foamed, and become a little brittle. The nose is cracked. So this has gone to the extremes. This was 7 grams in total weight. Then we have another 9 gram ASA Aero. You can see here the front, that's probably the only bit of damage that I can detect on this one. And this one flew the furthest and had also good hang time. So ultimately, I would say the ASA Aero is the material of choice for a paper plane copy, or a, what do you call it, a paper plane conversion.
I guess so, yeah.
All right, one more launch for the paper plane, the ASA Aero. Not bad.
Not bad. That was a good shot I got there.